Okay, so this is 6.3 notes, day 2, and we are looking at a composition of functions. And there's two types of notation to indicate a composition of functions, f of g of x, or sometimes, and I've heard students say they like to call it fog, because it's f and then there's this little open circle. It's not a dot, it's a little open circle. So sometimes students will say, oh, fog, and I'm like, yeah, it's fog. Don't call it fog. But remember the function machine. What this means is that you're putting g of x inside the f of x, okay? So if you look at example 8, it says let f of x equal 2x minus 7 and g of x equals x squared plus 4. In letter A, we want to find f of g of x. So what we were doing with the function machine is we were doing a composition of functions. So the inside is x squared plus 4. Now, if f is the outside function, I don't want you to think of x as the variable x. I want you to think of it instead as input. That's what you're putting into your function. So if I have f of x squared plus 4, this really means, since f is the outside function, you're taking 2 times and you're going to replace x with the input. So this will be 2 times x squared plus 4 minus 7. So again, the x is not x, it's representing input. So that's 2x squared plus 8 minus 7, which is 2x squared plus 1. Letter B says find f of g of 3. Now, what's really neat is what we were doing with our function machine when we started with 5 and 3 and negative 3 and negative 1. Those are numbers, and we know how to do those. What would, if I cover that up, what's g of 3? Go to g of x and tell me what's g of 3? 9 plus 4, which is 13. So that's f of 13. So I can substitute for g of 3. Now I come over to f of x, and this is 2 times the input minus 7. So f of g of 3 actually has a value of 19. So let's look at example 9. f of x is 3x minus 4. G of x is x squared minus 1. In letter A, I want to do the composition of functions. And again, composition of functions means you're putting one function inside another one. So g of x is x squared minus 1. So if f is the outside function, you want to think of 3x minus 4 not as 3x minus 4, but 3 times an input minus 4. But my input is x squared minus 1. So 3 times your input minus 4. So 3x squared minus 3 minus 4 is 3x squared minus 7. Letter B. With numbers, you're just going to plug them in. So I have f of g of negative 3. So I'm going to do the inside. G of negative 3, you come here, and it says that's negative 3 squared, which I know is 9, minus 1. So that's 8. And then I have f of 8, which is 3 times the input, minus 4. 24 minus 4 is 20. Does this make sense? Okay. All right, example 10 says let f of x equal 4x to the negative 1 and g of x is 5x minus 2. Find f of g of x. Well, the first suggestion I have is I personally don't like 4x to the negative 1. To me, that's confusing. That 4 is to the first power and the x is to the negative 1. So I'm going to rewrite it as 4 over x. So anytime you see in the homework negative exponents, just rewrite it. So letter A says, let's find f of g of x. So this is f of 5x minus 2. And so right now, f is the outside function. And it says take 4 divided by the input. So it's 4 divided by 5x minus 2. Now we're going to be asked in letter D to find the composition of each one. So I want to go ahead and pause and do that for each one as we go. But I need you to write down the steps. Find a spot here, maybe at the top or somewhere where you have space. There's going to be 3 steps. To find the domain of a composition of functions. And then as you do homework, be using your notes to help you. Step 1, find the domain of the inside function. Step 2, find the domain of the answer. Step 3, the domain of your composition is where these two overlap. And this will make more sense as we do more of these. All right, so let's use these 3 steps in letter A. The inside function is 5x minus 2. This is a slanted line, okay? Now, can you draw that slanted line, y equals 5x minus 2, without lifting your pencil? Yes, it's continuous, right? Well, that means the domain is all real numbers. So every slanted line has domain all real numbers. Actually, every horizontal line has domain all real numbers. And I love doing my arms. Let's find this one. So if I do a vertical line, we have a problem. Like, vertical lines are like x equals 2, x equals negative 7. It's just that particular x value on a vertical line. So I need to be very careful with my words. All slanted or horizontal lines have domain all real numbers, because it goes forever left and right. With a vertical line, it's only that one x value everywhere. How about a parabola, a u? Can you draw that without lifting your pencil? Yes, and it goes forever left and forever right. So all of your parabolas, all your x squareds, are all real numbers for domain. Absolute values are v's. I can draw that without lifting my pencil. And it goes forever left and forever right. So you're supposed to remember that from what we've done with our graphs. The only problems, and we talked about this yesterday, are with square roots or even roots and fractions. You can't have 0 in the denominator. So those are your 2 main places you want to be looking. So, having said all that, if I look at 5x minus 2, the inside domain would be all real numbers, because it's a slanted line. My answer is a fraction. I cannot have the denominator equal 0. So I set it equal to 0, and I get 5x equals 2, divide by 5, x is 2/5. So the domain is everything except 2/5. Now step 3 says, find where those two overlap. Well, here's a number line with all real numbers. And then here's a number line with every number except 2/5. So where are they both shaded? Everywhere except the 2/5. So the domain for my answer is everywhere except 2/5. Okay? So we'll do plenty of these to figure it out. All right, letter B. If I want to do g of f of x, now we're going to switch the order, and it might be interesting to try to figure out, does order matter with composition of functions? So I want g of 4 over x. Now g is the outside function, so it depends on what's on the outside. I remember when I was in high school, I was very frustrated with composition of functions. I kept getting confused with where do I go, and I would get mixed up. So I'm trying to be as clear as I can so you don't experience that. So g of x says 5 times your input minus 2. So it's 5 times the input minus 2. So that's 20 over x minus 2. Now we want to find the domain. You have to do the domain of the inside. Well, x can't be 0 there. In my answer, x can't be 0. So they're the same. So that makes my domain kind of easy. So when you're doing this, make sure you circle the domain of the composition. Don't leave 3 different answers, and if I have to guess, I'm going to mark it wrong. Okay? Now, were these the same? Did f of g of x equal g of f of x? No, they're not the same. So it's not true in general. We will see a special case in the next lesson. All right, letter C. I need f of x. So this would be f of 4 over x. Now the outside function is f. And this is saying take 4 divided by the input. Well, then you can see a connection to dividing by fractions. Same as multiplying by the reciprocal. So my answer is x. Now let's determine the domain. The domain of my inside, 4 divided by x, I can't divide by 0, so x is not equal to 0. The domain of my answer, that's just like y equals x, that's a line. So it's all real numbers. Where they overlap, x can't be equal to 0. Okay? All right, example 11. F of x equals 6x to the negative 2. I don't like the way that's written, so I'm going to rewrite this as f of x equals 6 over x squared. G of x is 4x plus 5. Letter A says find f of g of x. So this is f of 4x plus 5. And then it's saying take 6 divided by your input squared. So this is 6 over 4x plus 5 squared. You can multiply that out or not, it doesn't matter. So that's the answer. Now let's talk domain. The inside function is 4x plus 5. What's the domain of that? All real numbers, because it's a line. That's how I know that. The domain of my answer is a fraction, and I cannot have the denominator equal to 0, so let's set it equal to 0. Do you guys understand back up here? I mean, you don't need to write x equals 0, because it's x equals 0. I mean, you know, but when they're harder, we do want to write them out and figure them out. So I subtract the 5 and divide by 4. So x can't be negative 5/4. So I look at where they overlap, and it's going to be x cannot equal 5/4. All right, letter B, g of f of x. this is g of 6 over x squared. And g says take 4 times the input plus 5. So that's 24 over x squared plus 5. Now if you're starting to get the hang of it, I can then do these without writing the domain 3 times. The domain of the inside is x is not equal to 0. The domain of my answer is x is not equal to 0. Those are the same, so the domain is x is not equal to 0. Do you guys see how you can do it then without writing it, if they're easy enough? All right, letter C, g of x. So this is g of 4x plus 5. G of x says take 4 times the input plus 5. So it's 4 times the input plus 5. So it's 16x plus 20 plus 5. So it's 16x plus 25. Then let's talk domain. What's the domain of the inside? All real numbers. What's the domain of the answer? All real numbers. Well, those are the same. So it's just all real numbers. Okay? You guys starting to get the hang of it? A little bit. Okay, example 12. Now these are all numbers. I'm going to do A and then I want you to pick up and do the rest of them. If I want g of f of 5, I come over here and f of 5 would be 15 minus 8, which is 7. And then g of 7 would be 2 times 7 squared. Please excuse my dear Aunt Sally. I'll do the exponent and then I multiply. All right, try the next 3. All right, when you're done, check them up here.